Have you ever stopped to think about how a massive, complex IT project actually comes to life? You know, how it goes from just an idea on a whiteboard to a critical piece of hardware humming away in a data center. Well, today, that's exactly what we're going to do. We're going to trace the entire journey of a mid-range storage solution from that first light bulb moment all the way to a fully operational system. From the outside, it can honestly look a little bit like magic, right? A company has a need, maybe they need better performance, or they're just running out of space. And a few months later, boom, a brand new system is running their most important applications. But what's really going on behind the curtain? How do you get from A to B without total chaos? That's the real question. Well, the answer is, it's the complete opposite of magic. It is a highly structured, super methodical process. Every single successful IT project is a carefully planned journey. It's guided by a whole team of specialists who move through very specific phases, making sure every single detail is checked and double-checked to guarantee success.
So, here's our game plan for this explainer. We're kicking things off with, well, the project kickoff. Then, we'll dive into site evaluation. That's all about checking out the current environment. After that, we'll see how the solution gets designed. Then comes the really tricky part, data migration. We'll follow that up with the super important step of data protection. And finally, we'll bring it all home as we go from design to a live production system.
Okay, Section 1. This is ground zero. Long before anyone even thinks about ordering hardware, there has to be a real business reason for it all. Maybe there's a performance bottleneck slowing everything down, or a critical app is about to run out of capacity. This first phase is all about customer engagement, turning that fuzzy problem into a concrete project with a clear goal.
So, how does this actually start? It usually happens in one of two ways. First, you've got the really formal route. A customer puts out a super detailed document called a request for proposal, or RFP, that spells out exactly what they need. But honestly, just as often, it starts way more informally. A sales team is just talking with a customer, they identify a pain point, and they start brainstorming a solution that gets the ball rolling.
Now, a project like this is absolutely nothing without his team. Seriously, think of it like a high-stakes relay race. The account executive, or AE, is the one who gets the race started and manages the whole relationship. Once things are a go, the project manager, the PM, grabs the baton and handles all the logistics, timelines, milestones, the whole shebang. On the tech side, the pre-sale solutions architect, or PSA, sketches out the initial big-picture design. Then, they hand off to the solutions architect, the SA, who dives deep and creates the incredibly detailed blueprint for everything. And finally, the last leg of the race goes to the implementation specialist, or IS, who takes that blueprint and makes it real, doing all the hands-on configuration and moving the data. Every single handoff is critical.
All right, the team is assembled. The first big technical job, surveying the existing landscape. You just can't build something new without knowing exactly what you're building it on. This is the site evaluation phase. And you know what? It's probably one of the most important steps in this whole process. If you mess this part up, you are setting yourself up for some project-ending headaches later on.
The main goal here is pretty simple, but it's crucial. It's all about answering one big question. Will this new solution actually work here? This means digging into everything. Server models, operating systems, switch firmware, you name it. The whole point is to find any potential compatibility problems before they turn into a 3 a.m. emergency call. This is also where you often uncover other things that need attention, like, hey, we should probably upgrade this network while we're at it. Now, to do this deep dive, the team uses some really cool specialized tools. First up, you have data collection tools like Grab. Think of these as digital detectives that automatically go out and gather thousands of little configuration details from all the hosts and switches. But then you have this mountain of raw data. So you use data analysis tools like Live Optics to process it all and turn it into charts and reports that actually make sense. Basically, one tool gathers the facts and the other one tells you the story. Of course, finding problems is only half the job. This is where remediation comes in. Let's say the analysis finds an ancient server driver that won't work with the new storage, or a switch with a known bug. You have to fix that stuff before you move forward. That whole process of fixing those issues, that's remediation, and it's absolutely essential if you want a smooth deployment.
Okay, so now the team has a crystal clear picture of the customer's environment. Everything's been checked, and any issues have been fixed. Now they can finally start the design phase. This is where all that data and analysis gets turned into a detailed technical blueprint for the new solution.
A really solid design is built on three main pillars. First up, the customer workload.
This means you have to understand the performance your applications need, which we measure in something called IOPS, input/output operations per second. If you don't size for enough IOPS, the system will be sluggish. Size for too many, and the customer just paid for power they'll never use. Second, network infrastructure. This is so important, especially for moving data around. You can have the fastest storage in the world, but a slow network will just create a bottleneck. And finally, storage requirements. You have to size the system not just for the data they have today, but for how much they expect to grow over the next 3, maybe 5 years. You want this investment to last. To turn all these requirements into an actual list of hardware, the team uses these incredible sizing tools. The best way to think of them as like a financial calculator, but for performance. You plug in all the variables, IOPS, capacity, network speed, and it spits out the exact configuration of drives and controllers and memory you need. For the really high-end systems, they use a tool called Power Sizer. For the mid-range stuff, like in our example, it's the Midrange Sizer. And the output from these tools is pretty cool. It serves 2 key purposes. First, it generates a file that a computer can read, like a JSON file, which gets fed right into the sales system to create a perfect quote. No mistakes. But second, it also creates a nice, clean document, usually a PDF, that the customer can read. It clearly shows them the proposed solution, what kind of performance they can expect, and how much capacity they'll have. This is what they look at for that final sign-off.
And now, we've arrived at what is very often the most nerve-wracking part of any storage project: data migration. The shiny new system is all racked up and ready to go, but it's just an empty box. The real challenge is moving the customer's most valuable asset, their data, from the old system to the new one, all while causing as little disruption as possible. This is where things get serious.
So let's talk about migrating block storage first. This is the stuff that runs things like databases. Thankfully, modern tools have made this a pretty slick 4-step process. First, you set up the network connection between the old and new systems. Second, you set up the import. Basically, you tell the new system where to get the data. Now, step 3 is the really clever part. You start the import, and right away, any new data gets written to the new system, while the old data copies over in the background. This keeps downtime to an absolute minimum. And finally, step 4, you do the cutover, which finalizes everything and makes the new system the one and only source of data.
Now, on the other hand, migrating file storage, think of your shared drives and home directories, that's a bit more involved. Why? Because you're not just moving files. You have to preserve this whole complex web of network shares, permissions, and user access. So it takes a few extra steps. After you prepare the source and connect the systems, you have to create and start a specific import session. The cutover in step 5 actually involves switching the network interfaces that people are using to connect. And then there's a final step 6 called commit that cleans everything up and makes the migration permanent. It's just a more delicate operation.
Okay, the data has been moved, the new system is purring like a kitten. So, we're done, right? Not so fast. Now we have to protect all that data. A storage system without a rock-solid data protection plan is really just a ticking time bomb.
See, good data protection isn't something you just tack on at the end. It's a strategy that is woven through the entire project. This timeline shows it perfectly. It starts way back in the pre-sales phase, where the architects make sure the system is sized with enough horsepower for things like replication. Then, in the post-sales phase, the solutions architect works with the customer to create a detailed protection plan. And finally, in the services phase, the implementation specialist actually builds it, tests it, and makes absolutely sure that it works as designed.
And that brings us to the final leg of our journey. The blueprints are finalized, the data is all moved over, and a protection plan is in place. It is officially time to flip the switch and go live.
This last phase is all about execution. The implementation specialist takes that super detailed blueprint from the architect and brings it to life. They do the final configuration, they run a whole battery of tests to make sure everything is perfect, and then they formally transition the system into a production state. At this point, the project itself is officially done. The system is live, it's serving real applications, and it's now covered by its long-term maintenance and support contract.
And there you have it, the whole journey, from start to finish. We've seen how a simple business problem gets transformed through this intense process of evaluation, design, migration, and protection. And what you get at the end is a fully functional, fully protected storage solution that was engineered from day one to solve that customer's original problem.
You know, this structured process has been the foundation of IT projects for decades, but things are changing. Data is growing exponentially, and the hybrid cloud is becoming the new normal. So the big question is, how does this process evolve?
How do you design, migrate, and protect data that doesn't just live in one data center anymore, but is spread all across the globe and in multiple clouds? That is the massive challenge facing the next generation of architects and engineers.